Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 10 on my linked list series. So far I cover 9 lectures and from lecture number 4 we started solving the problems on linked list. I am picking these problems either from Geeks for Geeks or Lead Code, and these all are most frequently asked interview questions in most of the FANG interviews also. Please do subscribe to my channel and please do encourage if you liking my content. Without further delay, let's get into today's. This is one of the lead code medium problem. The ultimate goal here is we need to remove the nth node from the end of the list. Okay, let's see this example 1, 2, 3, 4, 5. If we carefully observe, there are total 5 nodes in the list, and in the input we are going to have a n, okay, which denotes what is the node which we need to delete from the end of the list. Here n is 2, that means we need to delete the second node from the end of the list. That is nothing but 4 here. After deleting this, your list is going to look like 1, 2, 3, 5. So this is all about the problem statement. Let's get into our board for a better understanding. If my list is something this 1, 2, 3, 4, 5, 5 next is null, and if my n is 2, that means I need to remove here 4. Okay, this one I need to remove. So after removing this, my output is going to look like 1, 2, 3, and 5. 5 next is going to be null. Let's see how we can solve this problem. If we carefully observe, if this is our list 1, 2, 3, 4, 5, and then null, and our n is 2. The first naive approach can be count the number of nodes, count the number of nodes, and traverse till length minus n position and remove nth node. Okay, what I mean by this statement? Let's try to debug it. So here my total length is 5, right? So I need to go till 5 minus 2. That is nothing but third node. Okay, starting from this. Then I need to remove. If I go third node, so initial it is going to be here, and then it is going to be here, then it is going to be here. So I'm at the third node from the starting. Then what I'm going to do, this node dot next is going to be this node dot next. That is nothing but 5, right? So that the chain was broken here, then this node get deleted. Okay, this is the naive approach where we are going to count the number of nodes and we are going to traverse till n minus n, and then we're going to return the nth node. But what are the time and space complexities with this approach? The big O of n is going to be count number of nodes initially, and then big O of n minus k, n minus k, yeah, assume this is a k. Okay, so n minus k is going to be the next iteration to delete the nth node. So average it is going to be big of n. The space complexity is going to be big of 1 because we are not taking any additional list or else any additional data structure to process this request. Okay, let's try to code this first. And here you can see this is Geeks for Geeks SD sheet, and I'm onto the topic of linked list here, and you can observe here this question is one of the part of linked list curated SD sheet, and the same question available in lead code also. Let's try and solve this problem in the naive approach. So the condition first is going to be if your head dot next is equals to null. That means there is only one node, and your n is equal to 1. That means you need to delete that node. Then simply assign head is equals to null. That is the first one. Okay. Then what you are going to do next? List node is equal to, I'm taking one dummy node. Dummy node is equals to new list node of -1, and this is just for sake of covering the edge cases. Okay, so you can understand the importance of this while I'm writing the code. So dummy node, then dummy node dot next is going to be your head, and to traverse this one, so I need to have a new reference, list node car node is equals to dummy node, and I need a variable called length. I can take len to start counting the number of nodes. So the next condition is while node.next is not null. Then every time then I need to increment my len, then I need to move forward. Node is equals to node.next. After completing this while loop, I can able to know the number of nodes in the list. Then I need to have the leftover is equals to len minus k. Okay, I need to traverse till this leftover. Okay, that means for int I equal to 0, I less than leftover I plus plus. Till this, before that, let's reassign our car node to dummy node. Then every time what I'm going to do here is car node is equal to car node dot next. Then at the moment when I am at this position, then what I need to do, car node dot next is going to be car node dot next dot next, right? Car node dot next is going to be car node dot next, and it then return dummy node dot next, because the first node in this is going to be -1, so that is just I'm taking for sake of covering one edge case. I'm going to tell, don't worry. So here we are done. Let's run it. Yeah, it is n, not k. Yeah, it got run. So let's try to give another input case where 1 and 2 I'm giving. Yeah, let's try to submit this one. Null pointer exception. Okay, where is our condition? Yeah, here. Just do one thing. As soon as you assign the head, just return it. Return head. Yeah, so it got submitted successfully. So this is the Navi approach, I can say, because we can achieve this problem in optimized way. Okay, let's try to get into that approach also. So the next approach is going to be why we need to count the number of nodes. Okay, so can we do without counting the number of nodes? Yes, the second approach this is. So what we are going to do here is, if my k is of size, I mean k is equal to 2, okay, and I have number of nodes as of 5. Okay, let's assume this is my list 1, 2, 3, 4, and 5. 5's next is null. Okay, then what I'm going to do here is, so assume like my fast pointer is here, my slow pointer is here, and by the way I'm going to use a concept of two pointers, okay, where I'm going to have slow and fast. And if you want to understand about this approach, please do watch my previous lectures where I covered about this approach. Now what I'm going to do here is, I will move my fast pointer by n positions. That means if my fast is here, so if I move by 2 positions, then my fast is going to be at here, right? Then what I'm going to do here is, I'm going to move my slow by 1 position, my fast by 1 position, until my fast is equals to null, or else its next is null. That means what happened? So my fast is not null, then my fast is going to be here, then my slow is going to be here. Again my fast is not null, then my fast is going to be here, my slow is going to be here. Again my fast is not null, my fast is going to be here and my slow is going to be here. uh, there is a one small mistake, so don't look about only fast equal null. Let's look for fast not equal to null. Let's see that. Sorry for the inconvenience. So 1, 2, 3, 4, 5. 5's next is null. Initially my slow is here, my fast is here, and I'm moving my fast by 2 pointers. That means it will come to here, and I will check if my fast dot next is null. Okay, till that condition, I need to forward my slow by one position, my fast by one position. Let's see. Is my fast dot next is null? No. Then I'm moving my fast and I'm moving my slow. Is my fast dot next is null? No. I'm moving my fast and I'm moving slow. Is my fast dot next is null? Yes. Then I'm not supposed to move my fast. Rather, I need to connect to my slow is equals to fast, or else slow equal to slow dot next dot next. Anything you can do. Okay. So this is how we can solve this problem. Okay. In this case, what is the time and space complexity is going to be? Your time complexity again is going to be big O of n, and your space complexity is going to be big O of 1. But here you don't need to do that count operation additionally. Okay. In one iteration, you can complete this thing. So that's all about this approach. Let's try and solve this one. And I'm just remove, let's have it the base condition like that. What I'm going to do here is, again, I'm going to create a dummy node. Uh, Dummy node is equals to new list node of some -1. Then dummy node dot next is going to be your head, and then your list node slow is going to be at dummy node. I mean, it's going to point the same, and your list node fast also going to point the same. Yeah. Now what you need to do here is, first you need to forward your fast by the n positions. For that, for int I equal to 0, I less than n, I plus plus. Okay, then simply do fast equal to fast dot next. Okay, you're done. You moved your fast by n positions. Now you need to see while fast dot next not equal to null. Till this condition, you need to move your slow equal to slow dot next, your fast equal to fast dot next. And once you found a place where your fast next is null, that means your slow dot next is going to be slow dot next, and return dummy node dot next. Let's try to debug this code, okay, before submitting, so that we can able to understand. Here, this is, assume this is my list, okay, 1 and 2, 2's next is null, and I given n as 2. That means I need to remove the 1 and I need to return the output as only 2. Okay, let's try to debug the code. Initially, what I'm going, this condition is anyhow false because head dot next is not null. Then what I'm going to do here is dummy node -1 and dummy node dot next is head, and slow equal to dummy node, fast equal to dummy node. So what is going to do? So -1, a node will be created, and its next is going to be head, that is nothing but 1 and 2 followed by, then your slow is going to point here, your fast is going to point here. Okay. Now let's see. While I equals 0, I less than n, I plus plus, till that condition satisfies, move your fast equal to 1 position. So I equal to 0. Initially 0 less than 2, condition satisfied. Then your fast is going to be at this position. Then your I plus plus, that is nothing but your I will become 1. 1 less than 2, still condition satisfies. Then your fast is going to be at here. Then I plus plus, I will become 2 less than 2, condition not satisfied. Then you come out of this loop. Okay. Then at this point of time, your slow is pointing to dummy node, fast is pointing to 2. Now what I'm going to do? while first.next not equal to null. If we carefully observe, first.next is null. So this condition is going to be false. Then eventually what we are doing, your slow.next equal to slow.next.next. That means where you are, your slow is at here. Slow.next is equal to slow.next.next. That is nothing but 2. So -1 and 2 is going to be, and 2's next is going to be null. So this is how it will be. Then what you are doing, you are returning dummy node dot next. Dummy node dot next is nothing but this part you are returning. So this is a valid output 2, and its next is going to be null. Finally, let's try to debug the same case for a larger set of input. 1, 2, 3, 4, and 5. 5's next is null. Initially, I'm inserting one dummy node, and my slow is going to be here, my fast is going to be here, and my n is going to be here. Okay. Now, I equal to 0, right? So 0 less than 2, condition satisfied. Then my fast is going to be here. Then I will become 1. 1 less than 2, condition satisfied. Then my f is going to be here. Then I become 2. 2 less than 2, condition not satisfied. Okay, after completing first loop, then your slow is at here, your fast is here. Now, while fast.next not equals to null. So is fast.next is null? No. I am taking different color pen. So is fast.next is null? No. Then what I'm going to do? I'm going to increment my fast by one position, and I'm going to increment my slow by one position. Is my fast.next is null? No. Then again fast is going to be here, then slow is going to be here. Is my fast.next is null? No. Again my fast is going to be here, my slow is going to be here. Is my fast.next is null? Yes. Then it will come out of that while loop. Okay. Then what is the final step for us? You are done with this one. Then wherever you are, your slow.next is going to be slow.next.next. So then how it is going to be? You are slow it here. Slow.next is going to be slow.next.next. That is nothing but 5. So then your output is going to look like -1, 1, 2, 3, and then 5. 5's next is null. This is what we need. So at then you are going to return dummy node dot next. So it is going to return this list. So here you can see we remove this node 4. So let's run the same. Yeah, fast is equal to, yeah, let's submit it. Yes, it got submitted successfully. So these are the two ways which are in my mind on this problem. So I hope you learned something new today. Please do subscribe to my channel, and I'm going to post more valuable content in the future. And one small request, my videos are always going to be bit length because I am spending 90% on explaining and only 10% on writing the actual code. So I believe when I explain things in detail, you are going to learn more rather than I directly start writing the code. Thanks a lot. Bye bye.